Hello all, this is the second video on IoT series. Here we will see a practical example of home automation using NodeMCU and mobile Android app. Both NodeMCU and mobile are connected to the same router on local area network, no internet, no cloud. First we have to install the Arduino core on NodeMCU. You can check up my previous video on how to do this. Link is given in the description below. We'll be using a 4-channel relay board to connect the load and control from the mobile app. This is very useful board for home automation projects. This is a low enabled board, that is when low is applied to the input, the relay is on. First we'll check up the NodeMCU to control an LED from a local browser, web browser. Connect an LED at D2 pin, long lead of LED to D2 and short lead to ground through a resistor. You can check up my blog under ESP8266 on how to do this. Previous project is explained on how to control an LED from web browser. You can download the code from here. We'll be using the same code for the home automation project with a slight modification. You can upload the code and open the serial monitor to note the IP address allotted. Then you can open the browser, feed in the IP address to get this web page. From here you can click on the button LED on or off to control the LED over local area network. Now let us see the code. The code starts with including ESP8266 Wi-Fi.h header file. You need not install separately. It is installed along with the Arduino core. LED is defined at D2 and then you give the password and SSID credentials. Then we start the server using Wi-Fi server function at port 80. Under void setup, we use the SSID password credentials to connect with your router. Once the NodeMCU is connected to the router will provide an IP address which is displayed using this Wi-Fi.local IP function. You have to note down this IP address which we will be using later in the app. And then under void loop, we use the Wi-Fi client function to see whether any client is being connected. Here the client is the web browser. From web browser we will be waiting for the string which is sent by the web browser. We use the index of method of string function to verify the string, and then we switch on the LED or switch off the LED. The index of method will return -1 when no match is found. And then we serve the web page, HTML web page. Once the client is connected, this web page is served. You can open the serial monitor. You can see the NodeMCU is being connected to the router and IP address is allotted. You have to note down this IP address and then feed in the IP address in the local browser, web browser. You will be presented with the web page. From here you can click on LED on to switch on the LED and LED off to switch off the LED. Now let us start the actual home automation project. Before connecting the practical load, we'll be using these LEDs to check the code, and then finally we'll connect the load to the 4-channel relay board. One red LED is connected at D2 digital pin and a green LED is connected at D4 digital pin. The short lead is connected to ground through a resistor. After testing this project using these two LEDs, finally we will connect the actual load to this 4-channel relay board. The red LED is represented by a DC fan and green LED is represented by a AC load. The DC fan we are using is 5 volt DC fan and the AC load is a CFL bulb. DC fan is connected to relay 1 and AC load to relay 4. Now let us modify the web browser code. Here we have defined LED at D2. We will change this to fan. As we are going to connect a DC fan at the D2, we will define this D2 pin as fan and define the D4 pin as light. Once we test the project using LED, finally we will connect the load. Under void setup, you have to make this as both the pins as D2 and D4 as output. We use the pin mode function to define the fan as output and light as output. And then we have to make this initially high, as the relay board is low enabled board. Initially the load should be off, so we use digital write to make the D2 pin as high as well as D4 pin, that is where light is connected. Both are high, so initially the loads will be in off condition. And then we scroll down to the index of method. From mobile app, we'll be using 4 buttons to switch on fan, switch off fan, and then switch on light and switch off light. So for these 4 buttons, we have to modify the index of method. The first index of method of string is LED, that is fan on. The mobile app will send a fan on string when the first button is clicked. So the string dot index of is changed to fan on, and when this string is matched, we make the D2 pin on. We use the digital write as low, as the relay board is low enabled. We make this as low to switch on fan. Same way for button 2, the button 2 from mobile app will send LED fan off. So for fan off index of method, we make the digital write fan high to make the fan off. Same way we copy this 2 index of methods and then change it for modify it for light function. For the button 3 of mobile app, will send light on. So in this index of, we change the digital write of light on to low, and finally for the button 4, we change it to light off. Here we make the digital write light as high to make the light off. Finally we'll comment out the HTML code. As we do not need the HTML code, we just comment it out and then save the file. Click on upload to upload the code onto NodeMCU, and then open the serial monitor. Here you will see the IP address allotted to the NodeMCU. The IP address is allotted by the router, and it is not static, it is dynamic. It will change when the next time you start. So open a browser, feed in this IP address on the browser, and then send the string LED that is fan on, which will make the red LED off, and you send fan off, which will make the red LED on. Initially both these LEDs will be on, indicating that both the loads are off, as we are using low enable relay board. Now you send light on, which will make the green LED off. Send string light off, which will make the green LED on. Yeah, it is reverse, as we are using low enabled relay board. Now we will go for the actual connection to the relay board, 4-channel relay board. Here we will be using a standalone power source for NodeMCU. Removing the connection from USB from PC, we will be using this MB102 power supply board. This board has got jumpers, so that one rail can be made to 5 volt and the second rail can be made to 3.3 volt using these jumpers. And there are pins for 5 volt and 3.3 volt. This MB102 PCB can be plugged down to MB102 breadboard. You cannot use other types of breadboard. This will plug on to MB102 breadboard, so that the top rail is made as 5 volt and bottom rail is made as 3.3 volt. You can provide an external adapter to MB102 power supply board. This is the 4-channel relay board with optocoupler and NPN transistors to drive the relays. Each relay has got one optocoupler and one transistor, and the terminal connection. Under the terminal you get the connections. We'll be using a DC fan, 5 volt fan at relay 1 and AC load at relay 4. First let us start the connection. IN1 for relay 1 enable, IN4 for relay 4 enable, and the ground pin. First let us connect these 3 wires. IN1 is connected to D2. You remove the red LED and connect that IN1 to D2. And IN4, which controls the 4th relay, is connected to D4. You remove the green LED, connect it to D4, and then ground. You can remove the resistor and then connect the ground pin to ground. On the relay board you see a yellow jumper. You have to remove this jumper. There are 2 pins, that is, one is VCC and another one is JD VCC. As the NodeMCU is 3.3 volt device, you have to use both these pins. Remove the jumper, connect 3.3 volt to VCC and 5 volt to JD VCC. This is the actual circuit of the optocoupler and relay schematic. You have to remove the jumper, connect 3.3 volt at VCC, 5 volt to JD VCC. As it is low enabled, when a low is applied to the input, the optocoupler will conduct. In turn, it will switch on the transistor and finally the relay will be on. That is low enabled. Now when the input is high, there will be no potential difference between the 3.3 volt at optocoupler and the input. So the optocoupler will not conduct and the transistor will be off and the relay will not operate. This is the low enable function of the 4-channel relay board. Let us connect the VCC and JD VCC. VCC is connected to the lower rail, 3.3 volt rail, and JD VCC is connected to top rail, 5 volt. That is why we are using the MB102 as both power it can source. We are using MB102, and then we have to provide the power source to NodeMCU also. You can remove the USB connection and connect the short jumper to 3.3 volt rail. You can provide an external power supply. A maximum of 12 volt can be used, adapter can be used, and then you can switch on the power using the switch on MB102. You have to provide a ground connection to NodeMCU also. We are using that short black jumper wire for connecting the ground. All ground should be common. Now let us connect the DC load, DC fan, 5 volt fan to the relay 1. The DC fan has got 2 wires. One is positive, red wire is positive and black one is negative. This is 5 volt DC fan, small DC fan. Now let us see the relay connection. The relay terminal, each relay has got 3 connections. One is the center, one is the pole. Always connect the power to the load to the center pin. If it is a 5 volt fan, you have to connect 5 volt to the pole. If it is a AC load, you have to connect the phase or neutral to the pole. And the NC is not used. The lower one is NO, normally open. Always connect the load to NO pin. NO is connected to one end of the fan, that is red wire, and the other end of the fan is directly connected to the ground, that is the negative. So we'll connect the pole to the 5 volt. As the supply to the fan is 5 volt, you use a male to male jumper wire, connect it to pole and then plug it to the top rail, that is the 5 volt rail. The NC pin is not used. We have to use the NO to connect the load. So the red wire of fan is connected to NO pin, and the black wire of the fan is connected directly to the ground. You can use any ground, 3.3 volt ground or 5 volt ground, all are common. You plug this black wire to the ground pin. Now the first relay DC load connection is over. Now let us see the AC load connection. Here also 3 pins are there. Center pin is pole, bottom one is NO. To the pole you connect the neutral of the AC. Instead of connecting phase, it is safer to you connect neutral to the pole. And then at the NO pin, you have to connect one end of the load. That is, we are using a CFL bulb as load. One end of the load is connected to NO, and the other end is connected directly to the phase of the AC. You have to be very careful while using the AC load. Do not touch the relay board as when the AC connection is given. I am using a 3-pin power plug so that the phase and neutral is not changing. Here the green wire is ground, that I am not using. The phase is the red wire, and black one is the neutral wire. A 3-pin plug can be used so that the phase and neutral is not changing. While using 2-pin plug, it may change. So connect the neutral wire to the pole, that is the center pin. Connect the black wire, neutral wire to pole. The actual load is connected to the NO pin. The load we are using is CFL bulb. It has got 2 wires. The red wire is already connected to the phase already I have connected to the 3-pin plug and put an insulation tape. So the other wire black is connected to the NO pin. It is always safer to switch the neutral instead of phase. But even then, while handling the AC load, you should use proper insulation and do not touch the relay board once the AC load is connected. You should be very cautious, otherwise it is dangerous to handle the AC load. Now both the loads are connected. At relay 1 we have connected the DC fan load, 5 volt DC fan, and to relay 4 we have connected the AC load, CFL bulb. Now let us see the Android mobile app development using MIT APP INVENTOR. MIT APP INVENTOR is a web-based IDE. Open the MIT APP INVENTOR. You have to provide your mail ID to register the account, to sign in the account. Open the MIT APP INVENTOR. You click on New Project and provide a project name. Here we are providing project name as home automation. Space and hyphen are not allowed, but underscore is allowed. Provide a project name and click on OK. You will be presented with a project. The opening screen of the MIT app has got 4 columns. First is the palette column, which has got a user interface, layout, connectivity, and other useful sources and components. The second column is the viewer column, where you drag and drop the actual components. Third column is the components column. Whatever components you select, it will be listed in this column. And the fourth column is properties column, individual properties of the components you have selected. You can change the properties accordingly. Now from the layout, you just drag and drop a horizontal arrangement. This is just to provide a space at the top of the screen. You can set the width to fill parent and height as 15%. This is just to provide a space at the top of the screen. At the real time you can see the changes and do the properties accordingly. And from the palette side, you under user interface drag and drop a label. This is to provide the heading of the app. You can change the width to fill parent and height as 20%, and provide the text. This is the heading of the app. We'll provide text home automation. This is the heading of our app. You can set the alignment, text alignment as center, and from background color you can choose your color. And then under from layout, you just drag and drop a table arrangement. We need 3 columns and 2 rows. 1 column for image, 1 column for on button, 1 column for off button. As we have 2 loads, we want 2 rows and 3 columns. You can set the properties of this table arrangement, that is width as fill parent and height as just 20%. Now drag and drop an image. Select this image and you can change the properties of the image. Height and width of the image you can select as you need it, and then click on upload image. Upload a picture. Browse to the location of the picture and then choose the file. Here I'm selecting picture of a DC fan and then click on OK. Now the picture is uploaded and you can see the picture under image. Now you drag and drop a second image. Set the height of this image to 20% and width some 20%, and under picture, in the same way you click on upload, choose the file, choose the picture as the second picture is CFL bulb, and then click on upload. Now you can see the second image. Now drag and drop 4 buttons. 2 buttons for fan control and 2 buttons for CFL light control. This is the button 1. You can change just the text only. Other properties we'll change. We'll leave it. We'll change only the text and the color. First button is changed to fan on. Second button is fan off. And the third button 3, is light on. Fourth button is light off. These are the 4 buttons we'll be using to control the load. You can select the buttons and then change the color accordingly. You can change the color of all the 4 buttons. Now the properties of all the 4 buttons are set. Finally, from under the left palette, select connectivity and then click on web and drag and drop to screen. This component is a non-visible component, so it will not show up on the screen. It will be visible only under the bottom of the screen. The properties of the web component we are not going to change here in this screen. This is the designer screen. By default, this will open up in the designer screen. At the top right hand corner you see another button, blocks. Designer is there and then blocks. You click on blocks where we build the blocks. Click on that blocks and then click on button 1. It will show the options of the blocks. Select when button 1 click do. So when button 1 is clicked, what you want to do, you select this block. And then from web you click on web. Here you will see all the options. You select the green one, set web1 URL 2. So when the button is clicked, this URL is called set web1 URL 2. And then from you select a text block, empty text block. That is the first block under text. You can connect this text block to this set URL 2, and then double click on this text block, change it to your IP, and then / and fan on. This is for the first button. You have to change this IP according to your IP given to your NodeMCU. And finally you click on web and then select this call web1 get. That is the purple color. Call web1 get. This block you select and fix it here. So this is the final setup for the button 1. You can right click and then duplicate, change the button 1 to button 2, and then the text to fan off. Remember to change the IP address according to your NodeMCU allotment. And again you duplicate it, change it to button 3 and text to light on. Finally duplicate and change the button to button 4 and text to light off. So now all the 4 blocks are ready. Now from the top you click on build and click app generator. Now the build file is .apk file, which can be uploaded onto your Android mobile. You can upload it, you can transfer it using share it or any other transfer method. This .apk file will work on your mobile. To make any changes to this app, you have to use the .aia file. I have given the link, download link in the description below. You can download the .aia file and from open your app and import. Click on import and then select the browse to the location where you have downloaded the .aia file. Now this app designer will open on your screen. You can make changes, whatever changes you want, or you click on blocks, and very important is you have to change this text. You have to change the IP according to your NodeMCU allotment. Your NodeMCU is allotted a different IP. You have to feed your IP here. For all the 4 buttons, you have to change the IP according to your NodeMCU allotment. And finally, you can click on build app. Now this app will work according to your setting. Also from your mobile, you can download MIT AI2 companion for to view real-time development on your mobile. This companion is very important. You can download and install MIT AI2 companion. Once it is installed, open this MIT AI2 companion. This MIT AI2 companion can also be installed on your PC, but on mobile it is very easy to see the real-time changes. Now you have to connect with, you have to scan QR code. For that you have to click on connect and view the QR code. Click on scan the QR code. So this 6-digit password will be automatically taken up. Now this MIT AI2 companion is installed on the mobile, and whatever changes you do on the MIT app IDE on PC, it will reflect on your mobile. This is very convenient to see the real-time changes. Suppose you want to change the heading label, you just on your web browser mid tab, you just select that label, change that to change the text of the label. You can see the real-time change. Now let us see the functioning of the mobile app. Provide the AC supply and then open the app on your Android mobile. Now touch on light on. You can see the CFL bulb is on, and you can touch on fan on to see the DC fan on. Similarly, the fan off will switch off the fan. So both the loads, DC load as well as AC load, can be controlled using the app. But this is local area network connection and not cloud connection. Thank you for watching.